So far we were converting these 3D shapes into very familiar shapes like cylinder converted to cuboid, cylinder converted to cone, sphere converted to cylinder, and vice versa. Now let's do something else. This cylinder is converted into combination of solids. Now you can see this upper part is hemisphere and lower part is cone. So we want to find how many cones we can make like that. Okay, so this is an application question. That's why it is written that cylinder container is filled with the ice cream, and how many cones can you fill of this particular dimension, right? Which is, we have information provided like height and radius. Let's read the question. A container shaped like right circular cylinder, so this first shape, having diameter 12 centimeter and height 15 centimeter. Let's stop over here and let's write the information. So diameter is 12 centimeter. Let's start with the diameter. So this is 12 centimeter, 12 centimeter, and height is what? 15 centimeter. So this height is 15 centimeter. So 15 centimeter it is. Done? Now that's it. The ice cream is to be filled into cones of height 12 centimeter and diameter 6 centimeter. Okay, so cone it is given of 12 centimeter height, okay, and diameter is 6 centimeter, having a hemisphere shape on the top. So on top that is a hemisphere shape, okay. Find the number of such cones which can be filled with ice cream. So remember, whatever ice cream is there in the cylinder, we need to transfer into the cones, and how many cones we need to fill, right, to transfer completely. Remember, we are moving matter from cylinder to the cones. So this is a question related to volume. Don't use the formula for surface area, be it TSA or CSA or whatever essay, right? That's it. So let's start with the information which is given over here. Let's start with the cylinder first. So we have height, okay, let's say capital H, which is 15, right? We have diameter, so capital D, it is 12. Let's say 2 capital R, which is 12 centimeters. So guess what? Radius of cylinder is 6 centimeter. Let's write here as well, 6 centimeter. Done for the radius. Now let's do for this cone. So it's given that height is what? Into fill the height of 12 centimeter and diameter 6 centimeter. So height is given. So let's write H is equal to, 12 centimeter. Okay, 12 it is. And diameter is given, which is 6 centimeter. Okay, 6 centimeter. So 2R is equal to 6. So R is equal to 3 centimeter. Done? Now volume of this is equal to volume of this much. But remember, we need to find number of cones, right? So there are multiple of this one. So we are going to use that formula, that volume of cylinder is equal to N multiplied by volume of this solid. Now wait, before we move on, we know volume of this cylinder, very simple, pi r square H, and we are done with that. But here there is a combination of solid. Remember, so we need to form the formula for volume of this solid. So let's start with the cone. What's the formula for cone? It's a simple 1/3 pi r square H plus this is hemisphere. Okay, hemisphere means what? Half of sphere. So volume of sphere is 4/3 pi r cube, and we need to take half of it. 4 divided by 2 will be 2. So that is 2/3 pi r cube. Done? Can we take few things common out of this? I think we can take pi common, and 1/3, let's keep it as it is. We can take let's start with 1/3 as it is. Okay, so let's take pi common, and r square, let's take only pi only, that will also work. So pi here, then r square H by 3 plus 2 r cube by 3. Simple, right? So here we can substitute the value. Why have I taken pi common? You'll come to know when I'll cancel it this way with the formula of cylinder. Okay, so r square h by 3 plus 2 r cube by 3. We can take 3 also common. No need to bother the write 3 2 times. It's okay. Let's start with the sum. So we are going to compare the volume, formula for the volume of cylinder. Let's start with cylinder. Volume of cylinder is equal to what? Volume of let's say solid only, because there is no any specific name. Let's write cone in bracket for understanding. Cylinder, that is pi, remember capital R square and capital H as well. Here there is something different. Let's take 3 also common. So pi by 3. Now what's left? R square H plus 2r cube. Remember, don't get confused over here. If you are still confused at this point, just disregard this, ignore it, put the values, simplify and get the answer. That will still give you the correct answer. Okay, now why did I do this? See, this pi and pi get cancelled. So what's left? R square h here only, 1 by 3. Okay, and one more thing, yes, we forgot. We need to multiply by n, right? At the right time we remember. We need to multiply by n because there will be so many of these cones. Okay, so let's start. Here r square h value of r is 6 centimeter. So 6 multiply by 6 and h is what? 15 it is equal to, let's write here, let's shift this n here. So n by 3 here, r square. So 3 into 3, that is 9. H is what? 12 plus 2 into r cube. Cube of 3, that is 27. Okay, done. So let's keep it as it is. I'm not going to simplify further. I'm not going to multiply. You know the reason behind that. It is easy to do the cancellation. Right, so let's keep it as it is. 6 into 6 into 15 as it is. 6 into 6 into 15 is equal to n by 3. Now what's the value of 12 nines are? That is 108. Okay, plus 27 twos are, that is 54. Done. Now let's do the addition, then we'll shift and get the answer. No worries. 6 into 6 into 15 is equal to, okay, this is n by 2, n by 3, and 8 and 4 will give you 12. 2 carry over 1, 5 and 1, 6. Okay, and 1 here. Done. Now let's shift here. Okay, now we are going to shift it. This 3 will be in the numerator. This 162 will be in the denominator. So 6 multiply by 6 multiply by 15. 3 in numerator and 162 into denominator is equal to value of n. Okay, so can we use the table of 3 for 162? Yes, we can, because see, 1 plus 6, 7, 7 plus 2, 9. 9 is divisible by 3. It is present in table of 3 basically. So 3 ones are, let's see here, what do we get? That is 5s are, and 1 2, that is 4s are. Okay, 6 ones are, and here that is 9s are. Right? Now can we cancel further? I think yes we can. So here 2s are, and here 3 3s are. 3 1s are, and here 5s are. So I think that's the only cancellation we can do. Now let's talk about what's left in numerator. Let's start 2 and 1 and 5. So 2 5s are 10. Denominator, there's nothing. Okay, nice. So value of n is what? 10. Simple. So how many cones can we fill? Right, which is 10 cones. So whatever ice cream which is filled in the cylinder, right, we need to fill 10 cones of this size, of this dimension which is given in question, then it will be completely empty. So let's recall the concept. What is new in this question? We know that we are converting cylinder into other shapes, maybe cube or cone or sphere. We have done it, but this is combination of solid. You have hemisphere along with the cone. So you need to think of the volume first before we move on, right? And don't forget the multiply by n. Right? That's a mistake. If you don't do it, you are not going to get the value of n. Okay, done. So simplify, compare the volume, simplify and get the value of n, which is there are 10 cones.